Welcome to this PIR live event webinar brought to you by Partners in Research Canada. My name is Stacey Joyce and I'll be your host. Remember that you can ask questions anytime by clicking chat near the top left of your screen and typing your questions in the chat window. I will relay those to Sherry when it's time, and make sure that you click to send those messages to everyone as opposed to all panelists. And let us know your teacher's name, your school or your city, or perhaps the student's name who had a question, and we'll give you a shout out too. So today's guest is Sherry Yang. She is a software developer at the Center for Innovative IT Solutions at the Southern Alberta Institute of Technology. Thank you so much for joining us, Sherry. I'll let you take it away.
Hi, everyone. I will cut to the chase and present the presentation for the day. All right. All right.
I just don't see you full screen yet. We're on our way there.
Yep. Let me click. There we go.
Perfect.
So we are going to explore problem solving with code in the real world today. Again, I am Sherry Yang. I'm from Calgary, Alberta. And you already know that I'm a software developer. I work for Applied Research and Innovation Services for SATE. And this is our lovely main building. If you ever to come to Calgary, come visit us. Center for Innovation IT Services is where I work. And the typical lab that we have is pretty much a chaos, but this is one of the pictures that our computer lab is like. We work with RFID solutions. As you can see here with the cow tag, that is an RFID tag. And I also work with mobile applications as well as blinky lights. Sorry, I'm just going to, blinky lights. These are tabletops that we actually develop to run to show the guest where they're sitting. They will light up as the guests enter into the room. So the software development can go from getting a light to blink, or work with other technologies like RFIDs, getting to track cows, where they are. So it's a very broad spectrum that we're looking at. And my contact information is sherry.yang@say.ca. So we want to get right into the definition of code. First thing you do is Google what code is. And right there from Google that you'll see that under computing, it is program instructions that leads you to get the computer to understand your language and interpret that into a computer instruction that a computer can process. So today we're going to talk about problem solving with code. So the steps, there are key steps for problem solving with code that we're going to go through today. First one is to find out the problem. Two, we'll be finding the answer. And then we will improve our answer. And then list the steps for solving the problem. And then we will code based on our listed steps. And then we will improve. And then we get to play. All right, so first of all, we need to find the problem. So the problem that I have for you today is an adult elephant drinks 189 liters of water a day. How much water do 2 elephants need for 7 days? That's the key problem of the day. and then we will find out the answer. The answer, we know that one elephant one day drinks 189 liters of water. Two elephants for one day drinks 189 plus 189, which is 378 liters of water. And now we can find out how many, how much water two elephants need for 7 days, which you would get adding them 7 times. And the final answer will be lots of water and 2,646 liters of water for 2 elephants for 7 days. How do we go about to improve our answer? We know that this is our answer and this is the method of getting it from the basic addition. It's a math problem. But we can improve it by making it into a multiplication, like so. But can we make it even better? Yes, we can. If we were to assume that our final answer is x, we will know that 189 liters of water multiplied by 2, which is the 2 days that we're looking for, and 2 elephants that we're looking for, and 7 days. So this would be, we can find out our final answer with one equation. And we still get the same answer as 2,646 liters of water. Now we will go into list the steps for solving our problem of the day. So first of all, we'll list all the numbers in the problem, which is our problem would be, to recap, it's an adult elephant drinks 189 liters of water a day. How much water do 2 elephants need for, oh, here it says 5 days, but it's actually 7 days. And then we find the amount of water for 2 elephants, which is 378. And then we record that answer, and then we put that answer into the step 2, and then we find it out for 7 days. I had to change the slide based on the age group. And then we will show our answer. It's still 2,646 liters of water. So if we were to code the steps listed, I'm going to show you to code in JavaScript first. For those of you that's not familiar with JavaScript, it is an interpret language that uses in the browsers. You can see a lot of JavaScript used nowadays in a lot of web application, websites. It is a very high-level language. That means it's very user interactive. So people can, as a user, you can change it, and you will be able to see changes right away. All right. So we all know the problem of the day, and the comments are the double slashes in green that I have color coded. So we know that this is our step. So now we're going to initiate our variables with like leave a space to put our numbers in. So we know variable water for elephant is 189. And then our numbers of elephants are 2, days 7. Step 2 is to find the amount of water for 2 elephants. And then we record the answer from step 2. Now we have to leave a space for this recorded answer. So I'm going to call it water for 2 elephants. Right now we're initializing it at 0. And then our equation for the amount of water for 2 elephants is water for elephants times elephant. So water for elephants up here, 189 with 2 elephants. And then step 4, find out the amount for 7 days, and using our answer from step 2, which is water for 2 elephants. And then again, we will leave a space for our final answer. And our final answer equation is water for 2 elephants times the numbers of days. And then we will show our solution, which in JavaScript, I can have a pop-up box, which is triggered by this alert function. It's an action, which gives you a pop-up window. And then it will show this message: the elephants need the final answer, liters of water. And you will see something like so. Like a pop-up window that shows your answer. So can we improve our code at this point? There's always ways to make your code better, more efficient. So just like our final answer, we can slim it down to just one equation. So here, as you can see, that we have 2 equations going on for our final answer. So just to remind you that we have this equation that we actually got this final solutions to just one equation, and we can apply that to our code as well. So from this block of code in the background here, it can slim down to just one, like 5 lines of code, or sorry, 6 lines of code. And it will still give you the same answer. So your final equation is here, and you put your final answer up here. And then you still display your final answer the same way, and you will still have the same pop-up window. So just to demonstrate what this actually looks like on a browser, I will show you how this will work. So I'm going to take you, which takes us to play. I will take you to a browser. I'll exit out to the screen. And I am going to copy the code that's directly from my slide. And then I will go into here. This is a Google Chrome browser. Right click, and I will click on Inspect, which will show me everything that's in this web page in the browser. All right, so I'm going to go to the console part. You will see, I'm going to push this over so that you will see better. And I will go ahead and paste my block of code, which is okay. And I'm going to say enter. And there you go. You have a pop-up window. This is a Chrome version. You have a pop-up window that shows your final answer. And the browser is doing the calculation for you. You don't have to do any calculation. The browser knows that you have a variable with this value. If I can increase that a bit. You have a browser, the browser knows that you have a variable called water for elephants. So even if I do like if I call for water for elephant right now, it's going to show me that it's 189 because you've already initiated your variable in the console. And other ways that you can play with this basic code is that you can make it a calculators for the zookeepers. As you can see that I've already done that with C#. C# is a programming language that's a combination of C++ and Visual Studio by Microsoft. So I have a little nice elephant icon in my program, and I'm going to run it. And maybe oh, it doesn't look so nice. I'm going to shake it up a bit. All right, you see my desktop, and this is my program. And I preloaded our problem of the day, which is 2 elephants, 7 days. And I want to know, as a zookeeper, I want to know how much water I need for these elephants for 7 days. So all I have to do is click calculate, and it's going to tell me how much water I need. And this can go up to, like, I don't know, if I'm handling a bunch of elephants, and I just want to know how much elephant I need for these elephants in 1 day. I can simply use this calculators and find out how much water I need. And yeah, so this goes on. You can play with this, and this will be able to solve your problem with a simple change of numbers, and it will calculate for you. And that's the part of software programming that will actually get you to use your code over and over again and make it into a tool, which is very useful for anyone that will encounter the same problem. For more advanced variations, you can add new animals, you can put in more options. Instead of water, maybe you want to calculate how much food they need. So that is also a way to change up the application and the logic. So back to our slides. To review, today we've walked through the steps for problem solving with code. First, we find out the problem, and then we find the answer. We improve our answer, and we list the steps for solving the problem. We code the steps that's listed. Of course, we already know that our solution is already improved. And then, again, we can improve our code to see if there's anything that we can do to make it even simpler. And then we play around. That is my slide for the day, my presentation for the day. So if you have any question, don't hesitate to send me an email at sherry.yan@state.ca.
Thanks so much, Sherry. So we do have a few questions coming in already. Just a reminder to anyone who wants to ask a question, you can pop that through to us in the chat function of Zoom, and just make sure that you change your to field there to everyone so that other students can see your question too. So I do have a question from McGilvery PS, and they want to know, what does the VAR at the beginning of the code lines mean when you were showing us that JavaScript code?
VAR means variable. So that is the way that JavaScript interpret variables. So variables are the items that you need in your block of code. So you can initiate them up top. As you can see from the code that we have variables elephants, variables for the amount of water that they need, as well as the days.
Okay, so basically everything you need as part of your calculation that may change, that would be labeled as a variable in JavaScript?
That's correct.
Okay.
So in other language, they have almost the same thing. Some they don't always call variables. For example, in C#, you would initiate the variables by giving it the variable type, like integer, Boolean as true and false, dates, and the length of characters, things like that.
So variables don't have to be numbers then?
No, variables can be anything. Anything.
Many things.
Yeah, many things.
Great. So I have another question here from Dara, who would like to know, how did you learn how to code?
How do I learn how to code? First of all, you have to love math. I think that's very important, because having the program instructions to assist you is to calculate things to begin with. It gives you use the computer power to solve your problem. Most of the time is to calculate things, to derive the answers for a certain problem. So math is somewhat important in the love of programming. And second, you have to love and always encourage your own self to solve problems. You want to find out the answers for something. That's the key. How do I learn? Like begin to learn is I always wanted to know how this one thing works. So when I first got in touch with a computer, I always wanted to know, oh, how do I make that? How does this work? And that's why I got into the nitty-gritty of the behind the scene sort of part for programming.
Okay, so I think you just ended up answering another question. We're very efficient today. Owen in Hamilton wanted to know, did anything inspire you to learn to code? Was there anything else that was your inspiration?
Because we're so close with technology nowadays, because me being me, I like to know how things work. When I stumble upon a website, I love the neat animation that they have. I wanted to know how that worked. And I would go ahead and find out, do a bunch of search, and as you can see, you can easily, on a browser, right-click, inspect, and know how the actual browser work with the code that it was given by the maker of the website. And then you can go from there to find out how they make this magic animation or magic pop-up window work.
So I have a couple related questions here for you while we're on the topic of getting started in coding and what was your spark to get you going that direction. But how many years did you go to school to learn all this stuff about coding? And also, how long have you been coding? Those questions came from Ms. Wright's class at McGillivray Public School and from Sienna in Ms. Zorzetto's class.
So there are programs in universities that you can take. Software engineering is one of them. That takes 4 years. Computer science as well. That takes 4 years. I personally did the diploma program here at SAIT, and that is a 2-year ICT program, Information Communication Technology, specifically in software development. So from the 2-year program, I get to know how to program in Java, which is another programming language, and that I also learned how to start building a software application from architecture, which is planning, to the actual execution of code and best practice in the industry. So there's different ways to go about it. There's also, like, you can self-taught a lot of HTML, CSS, which is the basic web page coding. Those are very easy to pick up. Yeah, so it varies from different institute, and it may take years. For me, even today, I'm learning new things. So technology is something that you want to always be up to date with. So I am constantly learning. I want to know the latest trend, and again, if I find something that I want to know how it works, I always go and search more, and you find yourself being a very good Google user in the end of the day.
Okay, great. So I now have the same question coming again from 2 different directions here. Emerson is a grade 6 student, and also we have Mr. Wigmore's class, and they both want to know, where is a good place to start coding for an elementary student who's interested?
Basic HTML is very simple to pick up. You don't have to, because you do see, for example, a website. You can design your own website and then apply it right into code. and then see the result right away. You don't need extra compilers or libraries. So I think HTML and CSS is the very basic things to begin to code. Again, JavaScript, if you like to see calculations, get the computers to do the work, yes, JavaScript is a great way to see those in actions. But for a full inclusion of a fast working web page, HTML and CSS is the basic that would be good for, did you say grade 2?
Grade 6.
Grade 6. Grade 6, yeah. Yeah, I think grade 6 is a good time as well, but HTML is, since it's so simple, you can even start earlier, from grade 4 if you like.
And don't worry, Emerson, grade 6 is not too late. I started learning HTML 2 months ago, so never too late. Ivy in Ms. Zorzetta's class would like to know, have you ever made a mistake?
Yes. So part of being a software developer is that you're when you finish a product, it's not when you finish a software like my elephant water calculator, like my calculator, I have to go in and try to debug it. Debug is pretty much what it sounds like. You're trying to get rid of bugs. So if my application have any weird things that happen when I click on certain place, then it is my job to find out why does it happen like this? How can I avoid it from happening? So we have to make sure that we understand the user's point of view as well as the actual logic of the application. So the calculator has to do the right calculation, and we also have to understand how the user interact with your application and go from there.
And you said there's almost always a way to improve your code.
There's almost always, and yeah, like I don't want to say it's mistake, but it's just something. Sometimes we don't consider every level when you're coming into making a software. Some developers may make a lot of assumptions, and assumptions are not always good in the IT industry because you don't know who is your user and how are they going to interact. So you have to think of all aspects.
So we're almost out of time. I'd just like to finish off with kind of a two-part question. First, you mentioned JavaScript and C#. What are the different coding languages that are common? What applications do they have? And also, what kind of career paths can you follow with coding?
You could be a software developer like me. I'm going to answer backwards. So, yeah. Career path, you can be software developers. You can be a programmer who only does a certain types of code. Like you can focus on one language and one language only. For example, Java. You can be a Java developer. You can be a mobile developer, which is iOS developer or Android developer or Windows mobile developer per se. Other ways to go through the code, like being a programmer, because you know how to work with computers, there are different aspects of programming that you can go into. You can be a database analyst. That's also another part of coding that you will eventually learn about. That's how you keep your data, and that the data management, that's all about database. What was that?
So what other careers could these students pursue if they wanted to use coding skills?
Yeah, so career, like I said, you could be a developer. Other careers, because software is being widely used in all industries, so you can basically be in any industry. Let's say oil and gas, It's heavily used in Alberta. They do need IT people. They use developers to help their software. For example, a telephone company, Shaw, TELUS, they will need software developers to improve the programs that they have. Yeah, so you can work in all kinds of industry, doing what you do best, which is software developing or a programmer. I forgot the question that you asked before.
So what other languages would programming occur in? And would someone who's a web designer use coding skills as well?
Yes. Web designer they do draw the framework and design the look and feel of a website, but they should understand the basic structure of HTML, CSS, JavaScript to know how each feature that they design works, and to better communicate with the developer. And that is, designer and developers comes hand in hand, because developer needs to know what the designer means by a certain box, a certain color, and then the designer needs to know how the developer works with their design to make seamless look and feel for the user's perspective.
Great. Well, I think we are out of time. We've already gone a couple minutes over because I wanted to get to a few of those last questions, but that is all the time we have today. So thank you very much, Sherry, for taking the time, answering our questions, sharing your expertise, and going through an example with us.
Thank you so much for having me.
So for anyone who wants to learn more about coding, you can join us for another PIR live event webinar to start out your hour of code if you're doing that on December 8th. More information on this and other PIR live event webinars is available at pirweb.org. Thanks for tuning in. Have a great day, everybody.